Alright, so for this last part of chapter 2 in 2-7, we're going to look at percent of change. And I really kind of condensed this lesson so that we kind of get the basic fundamentals of how to relate proportions, what we learned from 2-6, with percentages. So for the previous lesson, you saw proportions by finding the variable from two equivalent ratios. And then now you will calculate proportions by comparing them, the ratios, as percentages. Right? So just remember, percentages can be write as a fraction. Right? And I have 25%. I know that percentages are always over 100. Right? So another way to write 25% is 25 over 100. And if I have a fraction, I could write that as a proportion. So let's look at some examples first. It's really related to your quiz. New vocabulary right here. You're going to have percent, part, and a whole. We'll talk about that. So numero uno. Alright. You got a buddy named Tyler, and he got a grade of 25% on his multiple choice history final that had a total of 80 problems. How many problems in the final exam did Tyler answer correctly? Alright, so as you are writing these problems, I want you to keep in mind this. What is considered the part and what is considered the total? Alright, so what we're going to do here is that I want you to circle, circle the word in the problem that is talking about the part, and I want you to box the one that says total. Okay? Alright, so let's read this problem again. Tyler earned a grade of 25%, right? That's going to be right here when you have the percent value on his multiple choice history final that had a total. So that is the key word, right? When you have total of 80 problems, right? That is what I'm going to box, right? Because I know that is going to belong to my total. And how many problems on the final exam did Tyler answer correctly, right? So that the problems that Tyler answered correctly is considered my part because it is specific. When you're talking about something specific, that is part of the total that we see here. So let's set this up in my equation. Check it out. Okay, we have that right there. All right, and we see that we have a total of 80 questions. Right, 80 questions. And then I'm going to leave my parts, right, as X. Because I don't know that question. I don't know how much he answered correctly, right? That's the question I'm asking. So I'm going to leave that as X. And look, I solved the proportion already, right? I just related it to a percent because I know percentages are always out of 100. So once again, I can use what I know about cross multiplication. So these are going to cross multiply, and then these are going to cross multiply. Alright, just like that. Alright, so once I do that, I know I get 100x. 100 times x, and then I get 80 times 25. Let me simplify that. As I do this problem, I'll get 2,000. So to get x by itself, this is 100 times x. I'm going to undo that by dividing both sides by 100. Both sides by 100. This cancels out. And a cool tip for this right here, if you are ever dividing both numbers with a lot of zeros, you can kind of cancel out the zeros. So let me use a different color to see that. Right, this 0 can cancel out this 0 right there, and then this 0 can cancel out this 0 right there. So then I'm left with 20 over 1, and that is the same as x equals 20. Right? So that is my missing number. And what does that mean? Let me give you a visual of what that looks like. Okay. So since I know 25% is equivalent to 1/4, think about 25% as quarters, right? You need 4 quarters to make $1, 100%. Right? So if I say 80 is kind of like my 100%, right? Tyler only answered 20 questions correct, right? And that's the specific part, right? In the total number of questions, which is 80, right? This is total questions right here. All right, so that's example number 1. All right, when you try to find the part, right, the specific part of it, and these are actually scaled at the same value, right? 25% is the same thing as 20 over 80. So good thing to measure whenever you get something on your test, right? All right, let's look at another example. At a football game, 65% of people were attending the supporting home team, while 35% were supporting the visiting team. If 1,300 people attending the game supported the home team, what was the total number of people attending the game? So let's look at this right here, right? Just keep in mind this equation when you are relating a ratio to a percent, right? And once again, I want to circle the description that talks about the part and then box the description that talks about the total. All right? And this is interesting. I have 2 percentages, right? But the question is asking me if 13,000 people attending the game were supporting the home team, I need to look only at the percentages that's related to the home team. So 65% of the people attending supported the home team. This is the percent that I need, okay? Not this one. Right? 35% is from the visiting team. Right? I need to look at the home team. So note that right here is going to be 65. And if 1,300 people attending the game supported the home team, right? So this is the home team is specific. So if that is specific, that is part of the whole. I would say 1,300 people is the part, and you circle that. The question is asking me, what is the total number of people? So that's the keyword, total, right? What is the total number of people attending the game? Okay, so this is what I don't know. This is what I'm going to call X, right? Because I don't know what that value is. So let's set it up. Once again, I am going to get all right, 1,300 over X, right? Because I don't know what that total value is down there. So 65%, all right, 1,300 people for the home team, right, over X. Okay, so once again, let's do cross multiplication. And these are going to multiply like that. Cross multiply. And then you're going to get 1,300 equals 65x. Right? Another cool thing about when you multiply with a number of bunch of zeros, if you multiply 100, you just add 2 zeros after the 1,300. So if you got this 2, and then add 2 extra zeros, 1, 2, 130,065x. And then now to cancel out 65 times x, I need to do the inverse operation, division. So divide both sides by 65, and that is going to give me x equals 2,000. Okay, x equals 2,000. That's my answer. And let's look at a quick visual of what that means. All right. So 65% is equivalent to 13 over 20. So if I had 100%, right, 65% is only within this category. That is the same thing as if I had 1,300 people in the home team, right, out of 2,000 people, which is my total people, right, for all teams. Okay, so that is what I found, right? Remember, when you have a ratio, right, you always have the parts, right, specific over the total, the general, over percent, right? The percent right here, like that, and and just use cross multiplication to find that missing variable. Alright, go for it.